Good morning, Naveen. Today we are going to start from topic 2, computer hardware, multiplexer. Okay, so multiplexer is a hardware, the mandatory hardware required for building a computer. Okay, so now I am going to explain you the functionality of multiplexer, that is how the multiplexer is worked. Now, before getting to the definition directly, first look at this diagram. So, we already have some prior knowledge in constructing or implementing decoder and encoder. Yes. So, the same way we are going to construct multiplexer, but how it is differ from encoder and decoder, this is what we are going to study now. Okay. Now, look at the diagram. So, what is written inside the square? 4:1 mux. So, here 4 indicates the input lines, the number of input lines. So, look at the diagram. So, in this diagram, how many input lines were used? 4 input lines were used, and one is an output line, number of output line. So, one output line is coming out of the multiplexer after performing some operations. Okay. Now, coming to the definition. Multiplexer is a combinational circuit that selects binary information from one of many input lines. That is, it will always give you only one output line from the combination of many input lines. This is what called as multiplexer, and sometimes this multiplexer is called as mux. Simply it is called as mux. Okay. Now again come to this diagram. From the many input lines, it is selecting only one output lines. So this is what represented in this diagram also, and that's why it is called as multiplexer. Now you may have a question, how this circuit is helping you to select only one output from the many input lines. Okay, say see for example, inside the square box there will be an arrow mark. So if this arrow mark is pointing towards I0, out of 4 input lines, I0 will be given as a output line. And if I changed this arrow mark to I2, so it will give you a output line as I2. So this is simply same as in your TV. In your TV, there are many programs were offered for you. Yes or no? So there are many input lines, that is there are many channels, out of which using a remote control you are choosing only one channel. Only one channel you can view. Yes, at a time you can see only one channel from the TV. So for selecting one channel out of many channels, you are using a remote control to select. Yes. So in the same way, same as remote control, here for doing this task, for doing this selection, I am having a selector value, or otherwise called as selector lines. See, look at this diagram. I am having S1 and S0. So this is actually called as selector lines. Okay, and in this way this multiplexer is also called as a data selector. Okay, so multiplexer, you can call it as mux, which is nothing but to select one output from the many input lines, and it is simply called as a data selector, as we are using selector lines to select one output from many input lines. Okay, hope now you understand the definition and the diagram and the use of selector lines. Now look at the truth table. So there are two selector lines. S0 is an LSB, least significant bit, and S1 is the most significant bit. And now I am using these selector line, how the inputs were selected. If you feed 0 0 in selector line, the output selected will be I0. If you feed 0 1, the output selected will be I1. Similarly for the remaining two choices. Okay. So in this way, based on the selector line value, one output y is selected from many input lines I0, I1, I2, I3. This is what called as multiplexer. Now you may have a question. Why two selector lines were used, student? To answer this question, we should know the relationship between the input lines and the selector lines. We know already. So while studying Boolean algebra and logic gates, we know n is equal to 2 to the power m. Yes. For example, 4. If n is, in our case, the n is equal to 4. So 4 is 2 to the power 2. 4 is 2 to the power 2. As the n value was small, we can easily guess the value of m. Okay. Now the relationship is here, n is the number of input lines and m is the number of selector lines. As you are having 4 input lines, you need how many selector lines? 2. Because 2 to the power 2 is 4. Similarly, for example, if you are having 8 input lines, then what will be the value for m? It is 2 to the power 3, because 2 to the power 3 is equal to 8. Similarly, if 16 means 2 to the power m is 4, 2 to the power 4, 2 to the power 4 is 16. If the n value, number of input is 32, then it is 2 to the power 5. Similarly, 64, so the value is 128, the value will be evaluated from this equation, n is equal to 2 to the power m. So always keep it in mind, this is what the relationship between the input lines and selector lines. Based on this equation, the selector, number of selector lines are calculated. If you are confused with this formula, you may use this formula directly. M is equal to log 2 to the power n. So now example is also solved for you. M is equal to log 2, n is 4. So 4 can be written as 2 to the power 2. So 2 can be come to the front. So 2 into log 2, 2. 2 get cancelled. So the value is 1. So now for the 4 input lines, the number of selector lines required is 2. So this is important. You should know the relationship between the input lines and selector lines, because selector lines is playing vital role in selecting the output. Okay. Now next you should know how to implement the mux. So for implementing the mux, from this diagram, from this basic simple diagram, you have to derive expressions. Now I am going to teach you how to implement 2 input 1 output mux. So simply called as 2 cross 1 mux. So 2 cross 1 mux, how many input lines? 2 input lines, I0, I1. How many output line? Always only 1 output line. Now tell me how many selector lines required. Here the input is 2. 2 is equal to 2 to the power 1. 2 is equal to 2 to the power 1. So how many selector lines required? Only 1 selector line is required. Okay. Here in this diagram, I have added one more variable E. So here E is enable input. Okay. Enable is simply a switch for a circuit. If E is equal to 0, the circuit is in inactive mode. Okay. So whatever the input you feed in selector, there is no use. The output is 0. Now look at the truth table. If the enable input is 0, the circuit is inactive mode. So whatever the input you feed in selector line, it will not be considered. It's a don't care, and it will always give you 0 output. But if the value of circuit is enable pin is 1, that is the circuit is in active mode. So if you choose 0 in selector, it will select you I0, and if you give 1, it will select I1. Okay. So now the truth table is ready. Now for this truth table, we have to write the expression. So y is equal to, don't look at the first column, it is totally not required because the circuit is in inactive mode. There is no use to write expression for inactive mode. We have to write expression only for the active modes. Y is equal to first row, E is 1. So E into, what is the value given in S? It is 0. So S dash into I0 plus E second row, plus you have to add it, add the expression. E into S, the value present in S is 1, so you have to write it as S into I1. Now in both terms E is common, so I have taken it common, and in between I am having S dash into I0 plus S into I1. Now for the 2 cross 1 multiplexer, the expression derived is y is equal to E into S dash into I0 plus S into I1. That's all. So now simple AND gates and OR gates were used for constructing this 2 cross 1 multiplexer. Now using this, the multiplexer is constructed. Now as a homework, you please try the same for 4 cross 1 multiplexer. Okay, and after do it yourself, you just look at the 8 cross 1 multiplexer given in your book. So it will be easy for you to understand if you start from the base. Thank you.